So it was a bright, sunny Colorado morning. It was a Monday morning, coming back to work. I had just joined Manian's red team, and it was my first red team as an active participant. I was no longer shadowing. I had just taken the creative red team training course that we give at Black Hat as well as internally at our company. And I had learned all the things, and I was surely prepared for this red team. And, I woke up, got some coffee, took a shower, and was getting ready to do my first fishing campaign for the red team. We had spent the week before preparing, and we were sending out our fishes. I'm monitoring the access logs for Apache, and we're sending out emails, maybe one every 30 minutes to stay under the radar of spam. And essentially, I see a hit to our website. I'm like, all right, cool, but why aren't they grabbing the HTML application? Like, that's strange. A few moments later, maybe 10 to 15 minutes had passed, and then we saw a Linux user agent touch the web server and then pull down, and I see the user agent, and it's virus total. I got caught. And then in our global red team Skype chat, Nick Carr had said, "Is anyone doing a red team for X client?" And I said, "Yes, unfortunately that's me." He said, "Well, I just burned all your tradecraft." So I let out a big sigh, and I'm like, oh man, this isn't going well. Like, I joined Manian to do true red teaming, and I was so confident, I thought I knew enough. And I ended up being the daily scriptlet that day, which is something that Nick Carr does. He posts a column scriptlet every single day, and it's called #dailyscriptlet. That was me that day. So I looked in front of me. I was in the Denver Mandiant office, and I said, "Casey, I'm sorry, I just burned all your tradecraft." And he said, no, like, that's okay. Spehn, give me like 20 minutes, and maybe I can do some research and come up with some new tradecraft to use on this assessment. I said, well, do you mind if I shoulder surf you and watch what you're doing? And he said, sure, absolutely. So I walked around. We sat right across from each other. And he slowly started removing different tags from the comm scriptlet to minimize it. He was very, very close to getting it working. And I said, I think you're making a syntactical mistake here. He said, yeah, you might be right. I don't know. Give me 5-10 minutes to like put my headphones on and zone out for a few minutes to figure this out. And I said, okay. I went outside. I consumed some nicotine. I came back inside. And then he said, Spehn, you're right. I got it working. And that's how the minimalist comm scriptlet that Casey developed was born. And so now APT32, a nation-state level actor, uses the minimalist comm scriptlet to do their bidding. So one of the things that they use it for is a scheduled task to obtain the first level of persistence on a machine. And so if you're interested in learning more about APT32, you can go to FireEye's blog post to learn more about them. They're politically motivated. However, we're not focusing on APT32 today. Really what we're focusing on today is application whitelisting. And so first, a little bit about myself. I'm a consultant on Manian's red team. I joined them about 1.5 years ago. Before that, I'm a gamer first and a hacker second. I grew up hacking Diablo 2. If you ever heard of Blizz Hackers, I was an admin on there. I told you where to get your hacks from. Enough said. I also was a professional gamer for a while and played Dota, or Defense of the Ancients, for Evil Geniuses, and thought that's what I was going to do for the rest of my life. Unfortunately, at the time, they didn't make too much money. Now they are millionaires. So maybe I didn't go into the right profession, but I'm very happy with my decision. It's a lot of fun. So I'm a hacker second. Some of the things I'm known for are the iDroid project, which was porting Android to the iPhone. And I made a contribution to Open Embedded that allowed anyone to develop their own mobile operating system for the iPhone 3G, the iPhone 2, and a few other iterations, maybe like the iPod Touch first generation. It was a long time ago. My Twitter is Conscious Hacker, and my blog is blog.conscioushacker.io. So really the goals of this talk is for all of you guys to understand the efficacy of application whitelisting. Application whitelisting is the most effective security control that you can implement if you do it right. And that's what I really want you to get out of the talk. You know, like whenever I go up with application whitelisting and it's actually done right, I can't do anything as a red teamer. I'm completely shut down. So with that, you have to understand the importance of application whitelist bypasses in order to be able to tune your policy so that I can't do anything as a red teamer. And so with that, I want to make you guys capable of testing the efficacy of your application whitelist policies, as well as demonstrate the capabilities of application whitelist bypasses. So now we're going to talk about application whitelisting and what that is so we can get some definitions out of the way. So application whitelisting is really just saying like, hey, you can only run this stuff on a system, and that's it. And this image to the right is from Lee Holmes from Microsoft, from one of his personal blog posts. And so this is what he calls the Maslow's hierarchy of security controls. What I really want to focus on is app locker and allow mode and app locker and deny mode. So app locker and deny mode would be like a blacklist approach, saying you can't run these executables at all. You can't run this stuff at all. App locker and allow mode would be a whitelisting approach, saying you can only run this set of binaries or this set of stuff. So there's actually a report from Mandiant that was released earlier this year called M-Trends. Some of you may be familiar with it, some of you may not. So this is literally probably the only thing I'm going to read off my slides, but application whitelisting is another important detection and prevention control we see lacking in the organizations we assess. Without application whitelisting, end users and attackers have the ability to install arbitrary software in an uncontrolled manner. These weaknesses are commonly exploited by attackers in the initial compromise and established foothold stages of the attacker lifecycle and the incidents we investigate. So later in the talk, we will talk through a targeted attacker lifecycle scenario, and maybe an attacker that's not so enlightened and maybe isn't aware of these application whitelist bypass or this living off the land type of methodology. And then, you know, we'll talk through an enlightened attacker scenario in relation to application whitelisting and having that implemented. But first, we need to talk about, you know, what solutions are available for application whitelisting, like what can you use? And in this particular talk, we're only focusing on Windows, just so that's clear. There's application whitelisting for OS X and Linux as well, but I'm not talking about that at all in this particular talk. So the free solutions from Microsoft are AppLocker and Device Guard. AppLocker is probably the most popular one, and Device Guard is much more complex than application whitelisting. It's much more than that. It's really like a whole code integrity policy for the entire system. So it's a lot different. We're not going to focus too much on Device Guard today. We're going to talk about AppLocker a lot. And then like most next generation antivirus products has it in it, the ability to application whitelist. And then most endpoint defense and readiness products have it as well. Not all of them do though. There's a few other paid solutions like Bit9, Airlock Digital, and there's some other ones out there, but just to name a few from the paid side. So if we take a look at AppLocker default rules, it's kind of confusing. They really Microsoft calls it the AppLocker default rule, but really it's 3 rules in one that say, okay, if you're an admin, you can run anything on the system. All right, makes sense. And then everyone can run anything from the Windows directory, so C Windows. And then everyone can run anything from C program files. So I'd like all of you to just kind of think about that for a moment and think about maybe like the impact that might have from a red team or an attacker perspective, especially in the scenario of a more enlightened attacker. So this is actually how we enforce the policy. You can do this through local security policy, through the Microsoft Management Console snap-in, or through group policy and push that out to your domain or force or multiple domains or whatever it may be. And to actually configure the AppLocker policy and enforce it, you have to restart the system. So that's something to keep in mind. You know, you may not just be able to implement AppLocker across your organization and reboot every single system because you rely on it for critical business functions, just as an example. So now we need to talk a little bit about application whitelist bypasses and what they are. Like, let's get a definition. So really, an application whitelist bypass is really just using something inherently trusted by the application whitelist solution to achieve code execution. Like, that's the goal. Something trusted by the solution to achieve code execution. Great, so what's an example of that? So one example of that is regserve32.exe. This is also known as squibbly-do. You may have seen some of the posters at Black Hat, X vendor or product stop squibbly-do. We've actually seen that there. So Casey Smith, also known as @subt on Twitter, is the one that originally discovered this. And so essentially what he discovered is you could remotely retrieve and execute what are called COM scriptlets. Well, Chris, what does that mean? COM scriptlet, what is that? Really what it is an XML file with the ability to execute different Windows script host languages. So, for example, JScript or VBScript are two examples of Windows script host language. So if you look at this, the image at the bottom is actually straight from MSDN, which is also Casey's favorite video game. So all of you that say you want to be a red teamer and do research like Casey or Matt Graber or some of these other fantastic researchers that are out there coming up with a lot of the living off the land methodology as well as application wireless bypasses, you have to realize these people work at it nonstop. When I worked with Casey, I talked about, oh yeah, I've been playing some Dota 2 and doing this, it's so much fun. He's like, my favorite video game is MSDN. And that's kind of an inside joke between us. So if you actually look at MSDN, you can see, there are different parameters for regserve32. And so the /s here is really just saying, please be silent for us, suppress any error messages. We don't want the users to see anything when we're doing a red team or tip them off. The /n specifically says to not call the register component. And the reason why this is important is because to register a COM object on a system, it requires you to be a local administrator. Whereas unregistering, you just need to be a normal user. So it's fantastic for an initial access perspective, and it's important to understand that. So the /u, again, unregister, like we just talked about, and the /i is saying hey, I want to execute this scriptlet file. So it can actually remotely retrieve these scriptlet files. And then scrobj.dll is the specific dynamic link library that's related to registering COM objects. So let's take a look at Casey's original proof of concept that he released a couple years ago. So there are a lot of lines here, and it looks like XML, and you can see JScript in there in the C data portion, which really means content data within XML. It's defined within the XML standard. It's nothing special. But the most important part of this is line 11. This is the action that we're going to take. This is what we want to happen on the system. This is our code execution. So in this case, he just released a proof of concept that says to run calc.exe. So if we travel back in time a little bit to the day that Casey released this, how would we go about weaponizing this? There's been a lot of stuff done, a lot of blog posts written since then on how to weaponize it. However, immediately as a red teamer, as a pen tester, how do I start using this? Or as a blue teamer, how do I start creating more advanced payloads to audit my ability to detect and respond to things? So I'm one of the people that has written a blog post on regserve32, and if you go to my blog post, I describe the process to essentially weaponize the original proof of concept. And later we'll see further weaponization of this, but I actually have a quick demo for you guys of this blog post of how you would perform this process manually. So we're going to go ahead and fire up Metasploit and use exploit multi-script web delivery. We're going to take a look at the options, make sure we know what our IP address is, and we're going to go ahead and set up a web delivery attack via Metasploit to utilize the proof of concept that we just saw from Casey. So we're setting our IP address, our local port. How many people are familiar with Metasploit in here? I'm sure you guys have seen this kind of stuff a lot. Okay, great. Looks like there's a decent amount of hands. Oh, I'm sorry. We're going to have to restart this. That's my fault. I was wondering why it wasn't going on the screen, I'm good with technology though, trust me. So yeah, we look at the IP address. Like I said before, we're going to set the local host IP, we're going to set the local port, And then we're going to show targets. You can see that in the Metasploit framework, they do have a regserve32 option, but we're pretending like, remember, we went back in time here. This didn't exist yet. No one merged this into Metasploit. So we see that there's a PowerShell option. And so in here, you can see me fumbling a little bit, and my VM was running slow. But we're just setting the payload to Windows Interpreter, reverse HTTPS or reverse HTTP. We're double checking our options, making sure everything's set right. And then we're going to go ahead and do exploit-j, and we get our PowerShell one-liner to put into the original proof of concept that Casey released, because we want to actually use this on an assessment. And so we go into his original proof of concept, and we're going to replace this calc.exe with PowerShell.exe. Right? Makes sense. Like, actually pretty simple. So we're going to go ahead and save the file, and then we'll go over to our Windows host, and we're going to go ahead and execute regserve32 with the payload we just developed. So with regserve32, we talked about this earlier, about all the different options. S is going to suppress everything, N means to not call register, and U means to specifically unregister something. And the I is going to point to the actual proof of concept, which we're pulling remotely from my blog. And again, scrobj.yellow is specifically related to COM objects to register and unregister them. So we can see that our PowerShell.exe payload actually executed, and it went back to the remote address that we expected it to call back to. And then I don't actually interact with the session, but you can take my word for it that it actually did work. So just to kind of get that out of the way, we'll go back to our presentation. And so, wow, we've traveled back in time. We figured out, like, okay, initially, how did people weaponize this? How were people going to start using this? And this is a lot of what we saw across the industry, is people are like, oh, sweet, I can drop a PowerShell one-liner in here and use it for remote access within an HTML application. Like, that's pretty cool. So if we look at another example that's different than regserve32, that works in a different way, there's a developer utility called msbuild.exe, and it lives in C, Windows, Microsoft.NET Framework, and there are various versions of it based on version of .NET that you want to use associated with that. So msbuild has a built-in capability called inline tasks. Really what this capability is like an XML file that takes C# code and then compiles it and executes it in memory. So like with our, if we go back to our slide of like what is an application whitelist bypass, it's something that's inherently trusted by the application whitelisting solution that achieves code execution. And this will compile and execute code in memory for us. So this is great from an application whitelist bypass perspective. So we can talk through, let's pretend we go back to the day that Casey releases msbuild, because Casey also came up with this application whitelist bypass, and think, like, how do we weaponize this? Now, in regserve32, Casey didn't give as much information. With msbuild, he provided multiple different proof of concepts, not ones that just popped calc, but also executed shellcode. And so we can kind of talk through using his shellcode proof of concept in a few minutes here. But again, like, what we really care about is the red box, line 14. So this would be an idea of doing, this is how you would do hello world, and this is a proof of concept that Casey released. But again, he also released a proof of concept for shellcode injection. So that's a little more interesting, and I wrote a blog post on how to utilize the shellcode injection proof of concept that he released. So we're going to go through another quick demo of how to actually do that. And so we're going to go ahead and generate a payload with NSF Venom and set our output to C#. So we're generating shellcode with MSF Venom that's specific to C#, because again, msbuild takes in an XML file with the capability of an inline task function to compile and execute msbuild and the C# code within memory. So this is the proof of concept that one proof of concept that Casey had released for msbuild, which was using shellcode injection with C# and msbuild. And one of the things about this particular proof of concept he released is it is not fully weaponized. In memory, it is read, write, execute, and a lot of endpoint defense and readiness products look for that in memory. So your mileage may vary if you were to use this. So again, we're going to go back to Metasploit. We're going to set up our handler, the same old boring stuff that we kind of talked about with regcirc32. We're having to do all of this manually, and we're making sure that we have the right payload set. And I believe in this case we're using reverse HTTPS. Yes, see, you can see I make mistakes too. Don't be afraid to make mistakes. And go ahead and start the job, and then we'll switch back over to our Windows virtual machine and go ahead and execute this. So our job is running properly. We know Metasploit is ready, and we're going to go ahead and use MS Build, but we have to know the path of it, and that's hard to remember. But it's C Windows Microsoft.NET Framework version 4, msbuild.exe, and now we have this XML file that we've dropped to disk, and we see it's calling back to the remote address that we expect, and we can see that it's msbuild.exe, and it calls back to 443, which would be HTTPS. And then we're actually able to interact with this session. And I don't actually interact with the session on this one either, but for a demo later, I do. So go back to our presentation. We talked about regcirc32. We talked about MS Build. We've got an idea for what an application whitelist bypass is and some practical applications of them. But what about these very targeted attackers and their life cycle? One of the things about the targeted attacker life cycle is that the targeted attacker life cycle does not really change. And what I mean by that is like its initial compromise, its established foothold, its escalate privileges, do internal recon, move laterally, maintain persistence, and then complete the mission to steal money or data. Like that's generally like what we're talking about. And it doesn't really change, and I know there's a lot of varying opinions about this sort of thing in the industry with kill chain and the million other things that are out there. However, this is the way that I like to speak to it. So in this scenario, we have just kind of a basic attacker. And again, like here they're using a phishing email to use a word macro, using Visual Basic to download and execute a backdoor. They're using a run key to do persistence and establish a foothold. They're dropping Mimikatz to disk to maybe escalate privileges. They're using PSExec, and they're using the VPN because they don't have two-factor authentication on their VPN, and they're using web shells on their web servers to maintain access to the environment. They're using like some living off the land utilities to do internal recon, which is cool. But eventually, they steal money or data, right? So if you talk about like the scenario of, what I like to call an enlightened attacker, and I stole that terminology from Casey Smith, is like they do things slightly different. And you can already see, take a moment to like ingest this slide and try and note for yourself what is different. I'm going to highlight them in a second here for the stuff that we're going to particularly focus on in these scenarios that we talk through. And so the red boxes, pretty red boxes, pretty pictures. We have a word macro calling regcirc32.exe to a remote URL with a phishing email. They're using a run key with renamed MS Build to execute their backdoor. They're using Mimikatz in memory now, and now they're using wmy and MS Build to move laterally. A lot different type of scenario here, a lot different techniques. Again, the targeted attacker lifecycle does not change. It is the techniques that change across the targeted attacker lifecycle. So in a scenario with no application whitelisting, what do we think happens? Steal money or data. It's pretty simple. Like that's what's going to happen. Now, if you remember back to the beginning of the talk, we talked about app locker and its default rules. Let's talk through a scenario where we have app locker enabled with default rules. Well, if you remember, you can call anything from C Windows as a normal user, and anything in program files is whitelisted as well. So where would we get here? Ultimately, they're going to steal money or data. Like that's what's going to happen in this scenario. App locker with default rules isn't going to stop this. However, if we talk through a scenario where we've done proper systems development and determined the requirements for our users, and I see some people smiling at that, let's say we've done that and we've really tweaked or tested the efficacy of our application whitelist policy. If we've done that and we're aware and we're, what I'm going to call an enlightened defender now, and we know about these things, or an apex defender, as Casey likes to put it, you know, it's sure they can execute Word, but they're not going to be able to call regcirc32 within Word. So we stop right here. Initial compromise, it ends, game over. I can't do anything. Now maybe there's someone more skilled than me out there and they've done research and maybe they have another application whitelist bypass. But the thing I'm trying to convey here is like application whitelisting done right is the most effective security control that you can implement in my humble opinion. I go up against application whitelisting as well as EDR products all the time, most of the time in tandem, meaning both at once. And I've been in 1 or 2 scenarios where application whitelisting was done right. And I was like, man, I guess I'm like spending time researching new application whitelist bypasses this week because I don't know what to do. So introducing my tool, GreatSCT. I'll talk a little more about like why exactly I created this tool in the next few slides. However, it is open source. It is an application whitelist bypass framework. It's intended for both red and blue team. So like red team, obviously we can use this for initial access, lateral movement, persistence. We can use it in a lot of different ways. From the blue team perspective, let's say, you know, you actually have application whitelisting implemented. Okay, there's not that many people that have application whitelisting. You would be able to test the efficacy of your policy with my tool. Let's say you've got a brand new next-gen AV product and, you know, it's supposed to solve all your problems and everything's going to be good from then on out. You could use my tool to demonstrate that it's not going to solve all your problems. And we need to focus on the basics of doing proper systems development. And I like to relate this back to application security, how like in web application security, we've advocated for so many years to implement the security into the software development lifecycle. I view this as the same thing, like with systems development. If we actually like are capable of being able to determine all of the requirements for our systems and do proper systems development, we can implement application whitelisting from the beginning. However, a lot easier said than done. I don't want anyone to get me wrong about that. So really it's a framework to dynamically generate application whitelist bypasses based on user input. And so there's no static templates. Every single bypass that you generate within the framework is going to be unique. So kind of like the history of GreatSCT, I started developing this like about like 1.5 years ago whenever I first joined Mandiant. And you know, the version last year, there was no command line options. It was static templates based on proof of concepts, kind of like you're seeing in my blog post, that sort of thing. It was automating like that process. It's flagged as malicious by most antivirus under the sun. So okay, like now I'm running into the AV problem. What do I do about that? One of the legs up it did have on the new version, but this feature is planned for the new version, is it had a generate all function for blue teamers, where it also generates a CSV file and automatically track through Metasploit, a Metasploit resource file that ran every time a session came in order to give you a CSV that tells you like what bypasses worked and what didn't. So there is a feature planned for that in the future in the new version. However, I have some logic problems to solve and it's not implemented into the new framework. So in the new GreatSCT, there are robust command line options. Again, like it's dynamic generation, no proof of concepts at all. It does basic variable renaming obfuscation. So let's say, you know, you had shellcode equals blah. That would turn into random letters equals blah. And so there are some sandbox detection features. Really, I should probably change the slide to sandbox evasion rather than sandbox detection. And then there's a virus total check, so you know, like it's never been on virus total, and it's a unique hash, and it's never been seen before, and it's powered by Veil. How many people are familiar with the Veil framework written by Chris Trunster and Will Schroeder? So there were some hands. So Veil is really an antivirus bypass framework. And so I ran into the AV problem, right? Like, well, do I really want to reinvent the wheel and handle that problem yet again and write a new tool when there's already plenty of tools that solve this problem? No. So the story behind this is I was on site in the Seattle area with Trunter for an internal pen test. And him and I were hanging out after hours every night. We were grabbing a drink at the bar. and I was showing him, the old GreatSCT, and I was like, yeah, man, I've got like all this great stuff for it and all these great ideas. And he was like, I think you should rewrite the entire tool. And I'm like, come on, man, are you kidding me? Like, you want me to rewrite the entire thing? Like, and so the reasoning behind this is, Will Schroeder, or Harmjoy, was the person that originally wrote the framework portion for Veil. And in Veil 3.0, Trunster rewrote the entire framework so he understood it and what was going on because he was monkey patching his code all the time. I experienced the same thing with a former coworker of mine who used to work on this project with me, but he left the company since then and didn't decide to continue in the open source arena. So I was alone, and I was monkey patching Marcus's code all the time. And I was like, I don't even know how I'm going to solve this next logic problem. Things are so convoluted, I don't understand it. There are comments in his code that says like, this is intentionally obfuscated for intellectual property rights. No, really? Like, why are you laughing? So there wasn't much comments in the framework portion, so I decided, okay, maybe you're right, Trunster, like, I should rewrite the entire thing. And he's like, well, why don't you use like Veil's framework portion? And so he started explaining to me how there's the conductor that conducts the orchestra within his framework and how he wrote it and how it was designed. And I was like, yeah, that actually makes sense. It's kind of corny, and I'm going to make fun of you for it, but it does make sense. So really, again, it's based on Veil's project framework. I essentially forked Veil, stripped it down, modified it, took out what I didn't need, and added in some of the unique features that it had, like sandbox detection, checking the bypass of a hash on VirusTotal. And again, dynamic generation. Who's tired of hearing me say dynamic generation? So you can select things like your method of shellcode injection, virtual alloc or heap. Everything is dynamically generated based on user input. What input you give it is what you're going to get out of the framework, and that's something important to understand. There are custom interpreter stagers. There are unmanaged PowerShell payloads. So, like, I'm not sure if everyone in the room knows this, but PowerShell.exe is not actually PowerShell. It is system.management.automation.dll. One of the things that I did, another person at Mandiant or FireEye by the name of Daniel Bohannon wrote a PowerShell obfuscation tool called Invoke Obfuscation. One of the things that I did was take this and do a couple ports to Python for ASCII and binary encoding. The ASCII encoding is actually implemented in Bipeleader or Marcel's tool called CrackMapExec. So if you ever use CrackMapExec and a PowerShell payload in there within like the past year, you're utilizing my port of Daniel Bohannon's Invoke Obfuscation ASCII encoding. One of the other unique features about GreatSCT in particular is so who's familiar with James Forshall's .NET to JavaScript? Let's like get some hands. All right, there's like one hand or two hands. So this was like the #1 piece of tradecraft red team tradecraft that came out last year, in my humble opinion. And so James Forshall, he's works for Google Project Zero. .NET to JavaScript is essentially you feed a C# assembly into .NET to JavaScript. So like, what's an assembly? That's a DLL or an executable. In our case, we're almost always going to compile it to a DLL or a dynamic link library. And then we're going to feed that into .NET to JavaScript.exe, and then it is going to generate a snippet of code from a Windows script host language that we specify. Hence the name .NET to JavaScript, because JavaScript is a Windows script host language. So you can also do VBScript and some other stuff, and it'll like generate macros for you and things of that nature. However, the important thing to note here is that whenever it generates this code for you, it's generating you a VBScript or JavaScript snippet that dynamically loads the assembly into memory and executes whatever function you want because it has exposed it. So I got all of that working via Wine, and as I was corrected at Rocky Mountain Information Security Conference, Wine is not an emulator, so I'm not going to say it's an emulator this time, but I got it working in Wine. So again, dynamic generation, if you wanted to like start using my framework now, you would type /GreatSCT, and you would type use bypass, And then you can type list to see all the payloads. And in this case, we're saying we want to use the MS build unmanaged PowerShell payload, where we're going to feed it a PowerShell script that we could apply invoke obfuscation to if we wanted to, ASCII or binary encoding. And so there's all these different options that you can set. And eventually, the payload will be written out, and you can do your thing with it. So one of the things I really want to highlight here is like the basic random variable renaming obfuscation. So every box in blue is basic renaming of variables. We're just changing the name, so it's hard to understand what's going on in the event that we did get caught, where someone was trying to reverse our stuff. In the case of MS Build, the C# is all in the clear. It's not like it gets compiled because all that happens in memory. So, you're going to have your XML file or CSproj file on disk. So, if they find that, they find it and they have your code. However, at least my code looks like global00, but, with like advanced reverse engineers, they're going to recognize what this is right away. So line 26 is keying a payload to a Windows domain. In this case, we made it RMISC. Originally, these slides were designed for Rocky Mountain Information Security Conference. So like, why did I create this? Like, this seems like a red team tool. Like, are you really touting this as a blue team tool? No, I'm touting it as both. Like, it is both, and I firmly believe that. So the reason why I wrote this is because like there was no way to test the efficacy of an application whitelist policy. Like, there's no good answer I could give to a client that would ask me, we'd use an application whitelist bypass from Casey or whoever it may be, and they'd be like, like, how could I test this myself? And I'm like, I don't know, keep hiring us? And I don't think that's a very good answer. I really wrote it to like test application whitelist policy pitfalls. And so, number one, like we talked about early in the talk with the app locker default rules, inherently trust every default binary on the operating system. So anything Microsoft signed, we're going to trust that. It's good. Microsoft knows what they're doing, and there's no way, you could abuse any of their software. How does your solution whitelist, right? Like, is it doing it by hash? Is it doing it by file name? Is it doing it by directory name? We saw a lot of directory name in the app locker default rules. Is it doing it by packed executable info or metadata? Is it doing it by a code signing certificate? And so one of the other like pitfalls I've always seen is like I've harped on this a few times, I guess, is like not including this sort of application whitelisting development process in the system's development process. It goes back to my example of like with application security and implementing that into the software development lifecycle. I'm really like saying the same thing of like, we need to think about security from the start. And again, it is much easier said than done. Implementing application whitelisting is extremely difficult. So a lot of time we see exceptions for developers or executives without actually determining what the requirements are for their system. Like, what do they actually need to use on their system to get their job done? So there are some issues with that, but however, again, application whitelisting is the most effective security control you can implement if you do it right. So now, after I've rabbled on for so long, I'll actually show you my tool. So this particular bypass is called regasm, and it really just stands for register assembly. And as we saw previously, you can typically either register or unregister something. So this is the tool. We type /greatsct, and again, we type use bypass. We can type list. This is to show you like the payloads that are in it. I think I'm actually up to 27 in the development version, but I need to push that code to GitHub. But this is open source and out there right now, and the link will be at the end of the slides. So in this particular case, we're going to use regasm because it's different than the other bypasses we looked at, and I want to show that it actually does compiled assembly-based application whitelist bypasses as well. So in here, we can set a lot of different options, as you can see. We can check if debuggers are enabled, we can key it to a domain, we can expire the payload after a certain amount of time, we can key it to a certain host name. We have different options for how to provide it shellcode. It's not just using MSF Venom all the time. Like, if you want to use it with Cobalt Strike or maybe like a custom rat that you've developed, then you would be able to use it with that as well, using one of the 2, 3, or 4 options, depending how your shellcode is formatted with how your rat generates that shellcode. So this particular part of the demo takes a decent amount of time because, for whatever reason, sometimes MSF Venom is like snap, snap, and I can't actually snap, otherwise I would have. And then sometimes it takes like a minute to generate shellcode, and it's probably just an issue with my VM, or I was running too much stuff at the time. Who knows? Technology, like I said, you know, trust me, I'm good at technology. So again, it's just generating the shellcode, it's doing its thing. I like to tell you that there's like some secret awesome thing that I'm like doing behind the scenes right now, but it's just not true. So we'll give it a few more seconds, and eventually it will generate it and get everything compiled. So now we can select a name for it. We'll call it regasm. So one thing that's different in the newest version, it will actually print out execute with and give you the full path to execute the application whitelist bypass with. And I hit Control-C here because I like seeing you rage quit GreatSCT, because I almost did a million times whenever I was developing it. You know, writing code that generates code dynamically and obfuscates it, debugging that stuff is kind of a pain, and it drove me nuts at times. So it also generates a Metasploit resource file, just like Veil, using its framework, and we can feed that into Metasploit so we don't have to type all that stuff we saw in the regcirc32 and MS-build demos from the blog post I had written for, kind of pretending we had gone back in time, and Casey just released these bypasses and we're trying to weaponize them. So it's finally starting the Metasploit framework, set everything for us. Our job is running, our listener's running, like we're good to go. We'll double check the jobs. Okay, it is running. And then we'll go ahead and head over to the code that it generated for us. So it provides you the source code as well as the binary. And in here you can see public static void register class, public static void unregistered class. And again, this goes back to, if you want to register something, you have to be local admin. If you want to unregister something, you only need user level rights. So in this case, you know, we're going to end up unregistering it using the /u flag within regasm. And so now we switch over to our Windows machine, and we're going to type C Windows. And again, like I have this execute with in there now. I did that after I recorded this demo. So you'll be able to just like copy paste this in essentially in the future, instead of having to know the paths for all this. And it's generally like the same type of paths. It's either in System32, Sys1264, or within, you know, the Microsoft.NET framework. So again, we do regasm.exe/u to unregister. We're going to go ahead and check in process hacker, make sure that it's actually calling back. Again, we have regasm.exe, and we see it calling back to the remote address that we expect on the port, the TCP port that we expect. And we'll go ahead and go back over to Metasploit, and we'll see if we can interact with the session and get UID to make sure that everything is actually functioning properly. So we're going to go ahead and sessions-i2, because that's the session we want to interact with. We're going to type get UID, and hooray, we did it. We generated an application whitelist bypass that's all dynamically generated based on user input. So that's the last demo. I know people might be interested in like what my future plans are. I don't have a slide for it. I can say that I do have a lot of future plans. However, I'm still in talks with another individual about what we're going to do with GreatSCT in the future, and I don't want to reveal any of that until him and I have talked again. So it's one of those things where there is some great stuff planned, and the generate all feature, I plan on implementing that back in. And in relation to GreatSCT only, I also plan on finishing the Python port of Daniel Bohannon's invoke obfuscation. There are some other features that another individual and myself are talking about, and we're going to be submitting it to DerbyCon. Hopefully we get accepted there, and you know, if you happen to be at DerbyCon, come to my talk, or you know, keep an eye on me on Twitter, keep an eye on my GitHub if you're interested in this project and this sort of research. You know, I just want to thank everyone. I was very flattered to be made the keynote here. I just kind of you know, submitted a talk, and it happened. You know, on Thursday I was talking to someone. They were asking me when my talk was. They pulled up the schedule and they said, "Oh, you're the closing keynote," and I was like, "News to me." So hopefully you enjoyed it. I try to take it easier at the con so that I can have enough energy to try and deliver for you guys. And Thanks so much to the con for having me, as well as the sponsors and the other speakers and the fantastic trainers that we've had this week. And most importantly, you guys, the attendees, that make this conference awesome. So if there's any questions, yeah, absolutely.
Wondering if you accept community pull requests?
Oh, absolutely. So I need to add in like a contributions markdown file. That way, you know, there's some guidelines on how to do it. But yeah, absolutely. You know, feel free to reach out to me as well. And you know, you can talk to me about what you're thinking about or some ideas that you have, and I can point you in the right direction within the framework if you don't familiar, like just like deep diving into the code.
Quick follow-up: if we are aware of some application whitelist bypass technique, but we are too lazy to write the code. I'm not talking about anybody in particular, but if somebody was in this situation, would you accept like a GitHub issue saying, "Hey, consider implementing this"?
Yeah, absolutely. I would actually encourage that. So the question was, you know, let's say like you don't like, you know, a new application whitelist bypass or some research, but you know, you don't necessarily like want to write the code for it. Could I just like stick a GitHub issue on there and say, hey, consider implementing this? And I say, yes, absolutely. That would be fantastic. You know, I really like, my goal is to get everything complete. I want every single application whitelist bypass in this framework so that people can really test their ability to detect and respond, and hopefully in the future use my tool in more automated TTP adversarial type tools to provide a more realistic situation and analysis. Cool, yeah, great question. Thanks, Dan. Any other questions? All right, cool. I don't see any hands, so thank you so much.